So the next bit of 2D kinematics, we're getting into the kinematics part of it now. So we're getting into the SUVAT. So you've got 5 formulas for SUVAT. So let me just jot them down the side here. So you have V equals U plus AT. You have V squared equals U squared plus 2AS. S equals UT plus half T squared. S equals BT minus half AT squared. And S equals half U plus V times T. Now, these 5 equations are going to work with vectors apart from this second one, because we can't really square a vector at the minute. However, these other 4 formulas will still work, and remember, given those in your formula booklet anyway. And the good thing about doing SUVAT with vectors is you don't necessarily need to worry about pluses and minuses as you did in one direction. I know in one direction sometimes it's confusing whether you need a plus, whether you need a minus, whereas if it's in a vector already includes its direction. So let's have a look at example 5. The particle starts with initial velocity 3I minus j and moves with constant velocity. So remember, constant velocity means we can use SUVAT. After 5 seconds, its velocity is 1.5I plus 2j. Then we want to find the displacement from its initial position and the distance from its initial position at this time. So just put that as normal. So SUVAT. Well, S is what we're trying to find, and that's a vector. U, its initial velocity is 3 minus 1. Its final is 1.5 and 2. Its acceleration, we don't know, but we know its time is 5. So we can use the formula without air. So the formula without air is S equals half U plus V times T. Now I'm just going to underline which one of the vectors are. So S, U, and V. So sub in what we know. Half 3 minus 1 add 1.5, 2 all times 5. So a half times 5 is 2.5 times 3 add 1.5 is 4.5 minus 1 add 2 is 1. So S equals, well, I could leave it as that, or I could times it. So 2.5 times 4.5. If I left it as fractions, I could do that quick in my head. 2.5 times 4.5. 11.25 and 2.5. So that's its displacement. Now, to get its distance, remember we just used Pythagoras, so I use this notation to mean the magnitude, which means the distance is square root 11.25 squared plus 2.5 squared, which equals 5 root 85 over 4 meters. If I want to leave this exact answer, or if I want it as a decimal, the 3 significant figures will be 11.5 meters. Okay, the next one. So particle moves with constant acceleration. So constant means we can use SUVAT. Minus 1.53. Initially it's at the origin, so we know where it starts. And its initial velocity is 2.5. Find the time when the particle is at the point with position vector 1, 4. So again, we can use SUVAT. Now, S is its displacement, so S isn't necessarily this vector here, the point it's at. So I'm just going to show you what you would do if it didn't start at the origin. So to find its displacement, you do where it is now, take away where it started. So in this case, it does give us what, 4. But just in case it didn't stop the origin, if it started something like 1, 0, then its displacement would be 0, 4. So 0 along and 4 up. So its displacement is 1, 4. Its acceleration is minus 1.5, 3. Its initial velocity is 2, 5. And we want to find the time. So that means we want the one without v. So s equals ut plus half t squared. I'm going to underline the ones that are vectors. And if you noticed, each term is only one vector. There's none where there's two vectors times together. That's why that v squared one is the only one that doesn't work. Because v squared means v times v, vector times vector. So let's sub everything in. So 1, 4 equals 2, 5 t plus a half times minus 1.5 3 t squared. Well, we get two equations from this. We get the top one. So if we just look at the i's, we get 1 equals 2t minus 0.75 t squared. Yeah, a half times 1.5, which if we take it all over to one side, we get 0.75 t squared. Take away 2t plus 1 equals 0. And if we type that in a calculator, 0.75 minus 2, 1, we get t equals 2, or 2/3. Then if we do the same by the j's, the bottom numbers, we get 4 equals 5t plus 1.5 t squared. Again, take it all to one side, 1.5 t squared plus 5t minus 4 equals 0. And then type that in, 1.5, 5 minus 4. And we get t equals 2/3 or minus 4. And the answer we're looking for is the one where the t's are the same. So 2/3. T equals 2/3 seconds. Okay. So one more. So a particle of mass 2.4 kilograms. Actually, I'm going to, if I was you, I'd be doing an exam. I'll be highlighting all the key bits. So a particle of mass 2.4 kilograms moves under the action of a constant force. So constant force means constant acceleration, which means SUVAT. And the force is F. When t is 0, the particle is at the point of position vector 3 minus 1, and that's when t was 0, moving with that velocity there. And when t is 4, its position vector is that there. So find the vector F. Okay, well, we know we can do SUVAT. And since there's also forces involved, we know we can use F equals ma. So let's fill in what we've got so far. So we know that t is 4 because it takes 4 seconds for this to happen. We know initially it's moving with velocity minus 2, 5. S, well, it starts at 3 minus 1 and it ends up in 19 minus 5. So to work out how far it's traveled, or the displacement, given where it ended up. So 19 minus 5, take away 3 minus 1, which gives us 16 minus 4, hopefully. Yeah, and that's coming from, if I can just squeeze it up here somewhere, that's coming from AV is O to B, take away O to A. So we get from one place to the next, it's the last one, take away the first one. Its final velocity, we don't know, and we don't know the acceleration. So there's two things we don't know. However, if we want the force, we know its mass is 2.4, so we need the acceleration, So I can use this one to find A, then put the A into there to find A. So I want the one without V, so it's the same one as before. S equals ut plus a half at squared. Underline the vectors. So S is 16 minus 4 minus 2, 5 times 4 plus a half times times 4 squared. I'm just putting the vector at the end because that's how we usually write it. So you get 16 minus 4 equals minus 20. 4 squared 16 divided by 2 is 8 plus 8. Well, I'm just going to do a bit of algebra and move this vector to this side. So the opposite of minus 8 is plus 8. So 16 plus 8 is 24. Opposite of 20 is minus 20. So minus 24 equals 8a. Divide by the 8. So a equals 3 minus 3. 3i minus 3j. Like that. Okay. So the next bit is we will put it in here to get what A is. So A was 3 minus 3. So then we use F equals MA. Underline the vectors. So F equals 2.4 times 3 minus 3. So F equals 2.4 times 3 is 7.2. So 7.2 minus 7.2 evens. Yeah, and since that's with a vector, I'll leave this vector. If I want the magnitude, I will then use Pythagoras.